Welcome back to part 2 of Module 10, Lesson 3, where we're continuing our study into theoretical probability and simple events. We're starting off by learning about how to find the theoretical probability of simple events. It says that 8 disks are marked 3, 4, 5, 6, 7, 8, 9, and 10, such that each disk is marked with exactly one of these numbers. A disk is selected from a bag at random. What is the theoretical probability of selecting a disk marked with a prime number? Now remember, your prime number are numbers that are divisible only by 1 in itself, with the exception of 1. 1 doesn't count. So 2's prime, 3's prime, 5's prime, and 7 is prime. And out of the numbers that they've given us, all of its prime is going to be your 3, your 5, and your 7. So that's 3 prime numbers out of the total of 8 numbers that are given to you in the bag. Let's see what the textbook says on this. Give it a moment to load. The 8 disks are marked, so you can see right here the first thing that they wrote is the P prime, because prime is the event we're looking for, and you do need to do that on your homework and your test as well. The prime numbers were 3 out of the total numbers for 8. Now what they did not write was the formula, and I do expect you to write that as well, where the formula would be P event is equal to NFO divided by TO, number of favorable outcomes divided by total outcomes. From here, we're going to take and do some division. 3 divided by 8, we're not going to do that on paper right now, but if you did, you'd get 0.375, and to change that to a decimal, all you have to do is bounce that decimal 2 spaces to the right, change the percent sign, I'm sorry, bounce it 2 spaces to the right and insert your percent sign, and you get the 37.5%. So there's a 37.5% chance that you're going to select a prime number out of that bag. Now that takes us to extra example 2. Go ahead and pause the video and work this problem out on your own, please. Alright, the textbook wants to know what's the probability of getting a 1 on this spinner, and you can see that all the spots on the spinner have equal spaces. I started off by writing my formula, which is the same thing you need to do. I said probability of the event is equal to NFO, number of favorable outcomes, divided by TO, number of total outcomes. The number of favorable outcomes, the number of 1s are 1, 2, 3, so I have got 3 over, and then I have got, let's see from here, I've got 3, 4, 5, 6, 7, 8, so we have 3 out of 8 is going to be our answer that we have there. Let's see what our options are over here. We're looking for 3 out of 8, that's going to be this one right here. Then drag our 1, stick it right there, check the answer, and it checks. So you have a 3/8 chance, which is also the same as 3.75, which is also the same as 37.5%. Incidentally, that's the same number we had on example 2, so the math should be pretty hard as far as converting between those numbers. Now let's look at complements of simple events. Simply put, the complement of the simple event is not the event. So on that last problem we had, where we were finding the odds of getting a 1, the complement of that is what's the odds of not getting a 1. So if the 1 was the winning chances, what's the odds of losing would be that type of situation. Suppose you're rolling a number cube and the desired outcome is an even number. The success of rolling an even number and rolling a success is rolling an even number. However, rolling an odd number is not a success. These are known as complementary events. Okay? The two events combined are known as complementary events because they cannot happen at the same time. You cannot roll both an even and an odd number at the same time. Looking at this in words, complementary events are 2 events in which either one or the other must happen. They can't both happen at the same time, and the sum of their probability is 100%. Either you will win or you will lose. You cannot win and lose at the same time. In symbols, we would say that the probability of an event is the probability of A, that's your winning, then the complement of the event is written as probability of not A, that's a losing, also known as probability of A prime. That little tick mark above the A We call that a prime in math. And as an equation, we would say that the probability of A plus the probability of not A is equal to 1. The probability of winning plus the probability of losing is equal to 1. And remember, if you convert 1 to a percent, bounce that decimal 2 spaces to right, that's 100%. So you have a 100% chance of either winning or losing. No other options. So for scenario 1 here, they say, suppose you are rolling a number cube and the desired outcome is a 3. 3 is your winning number. What is the complement of rolling a 3? And it says drag the number of faces that make up the complement of the event. Well, the complement is the not the event, the losing thing. So a 1 will lose, a 2 will lose, a 4 will lose, a 5 will lose, and a 6 will lose. All of those are going to be your complementary events. Those are the things that you would lose. Now, you would think complement's supposed to be a positive thing. Not in math. You notice I don't hand out a lot of complements in math. It's not a positive thing. The complement of the event is not rolling a 3. In other words, the complement is rolling a 1, 2, 5, or 6, just like we found. Now we're going to move through some slides to see the relationships between the probabilities of the event and not the event. The probability of rolling a 3, that was 1 out of 6 right here, because there is 1, 3 out of all the numbers, 6 of the numbers. The probability of not rolling 3 is 5 out of 6, because there is 5 not 3s out of 6 numbers. And from here, if we were to take and add those up, 1 6 plus 5 6, that's equal to 6 over 6, also known as 1 or 100%. At 100% of the chance, you're either going to roll a 3 or you're not. There's no other options on that number cube. For scenario 2, they say, suppose you're spinning the spinner shown and the desired outcome is an even number. What is the complement of spinning an even number? In other words, what numbers are not even numbers? So we can say 1 is not even, 3 is not even, 5 is not even, and 7 is not even. Those are your odd numbers. Those are going to be your complements. The complement of spinning an even number is spinning an odd number, which is 1, 3, 5, and 7. It really is this simple on this part of the lesson. Scenario 3, suppose you're reaching into a marble bag with red R, green G, and blue B marbles. The desired outcome is to grab a red marble. What is the complement of selecting a red marble? Drag one marble of each color to make up the complement. So I'm going to grab 1 blue and 1 green. You don't have to drag them all over there because that's kind of redundant. Check your answer, and once again, that's correct. Blue and green are the complement. Red is going to be the winner. You're not dragging all the blue and green marbles over. You're just acknowledging the fact that getting a blue or green, that's going to be your losing marbles. And yep, that's it for that part. For example 3, Raphael is going to ride a roller coaster chosen at random. My roller coaster chosen at random would be Mr. Reach ain't riding a roller coaster. He don't do roller coasters. Anyhow, he wants to find out the probability of choosing a roller coaster with a height less than 250 feet. What is the probability of doing that? What do you know about the event and its complement? Well, the event is all roller coasters less than 250 feet. Its complement is all the roller coasters greater than 250 feet. So we're going to start off by identifying the complement of the event. The complement of the event is choosing all the roller coasters with a height not less than 250 feet. In other words, a roller coaster with a height equal to or greater than 250 feet. The equal to, it falls in that category as well. So select all the outcomes that make up the complement. Well, the Thunder Dragon is greater than 250. The Screaming Spider, I'm not getting on anything called a Screaming Spider. Forget it. It's not going to happen. Greater than 250. The Zipster's less. The Maniac is less. The Flying Eagle, that's greater. The Twister Wave is greater. The Triple Tornado is greater, and the Ultra Loop, nope, Mr. Reach doesn't do loops either. That one's going to be less than your 250. Check it. All of our answers here are correct. So how many outcomes made up a complement? We had 1, 2, 3, 4, 5. So 5 outcomes are going to make up the complement. That part checks. And now we're probably going to work on finding the actual probability. So we'll move through the steps to find the probability of the complement. So they did not start off with a formula. You need to start off with P event equals NFO over TO, number of favorable outcomes over total outcomes. And from here, the number of favorable outcomes, the number of things that are not less than 250, that was 5. The total number of outcomes was 8, so you have a 5 out of 8 chance of not getting the ones he's looking for. The complement, therefore, is going to be, put in the fraction, 5 over 8, except this is the same as saying the probability of choosing a roller coaster greater than or equal to 250 is going to be, once again, we're going to put in the same 5 over 8 because that is what the complement meant. Check it, and both of these check. Now it's going to be your turn. Pause the video and work extra example 3 on your own. This is the last problem in this lesson. Alright, the problem, once it says the goal, what they want to accomplish is to roll a 2 on a number cube. So now we want to find out what the complement is, the complement being what is not a 2. Well, not a 2 is going to be a 1, a 3, a 4, a 5, and a 6. We're going to write our formula. P event is equal to NFO, number of favorable outcomes, over TO, total outcomes. And now the event we want is not 2, so I have P not 2 is equal to, I've got 5 numbers that are not 2 out of 6 numbers total, so that's going to be your solution to that problem. This stuff's really simple, isn't it? Very refreshing after the last module. So D is going to be a correct answer, and boom, very easy math. Time for you to get started on your homework. Please let me know if you have any questions in class tomorrow.